Hello. Let's look at ROH alcohols. And the R variable group could be methyl, ethyl, or propyl. And it could be butyl and so on too. Okay. Now, we're gonna look at this ol name. That's the alcohol name coming from OL. That's the name ending when you see the names, right? And that's also OH is a hydroxyl functionality. It's a covalent functional group. It's different from K plus and hydroxide ion in the potassium hydroxide and sodium hydroxide. These are ions, right? Hydroxides are ions. They are very different. Okay. We are talking about the covalent molecules. The first one I want to compare with water. So water I can draw to show the hydroxyl functionality. Now I'm going to replace in methane one hydrogen with one hydroxyl group like that. Then it's one carbon, which should call methan, and then name ending up with ol, so that's methanol. So that's how you have it, right? So each carbon has 4 bonds, and also oxygen has a delta negative because of the electronegativity, and the hydrogen gets delta plus. So because of that one, they will form hydrogen bonding intermolecular forces, IMS, just like in the water. So remember, like dissolves like. They look like water, they should behave like water, right? That is true for only 1, 2, 3 carbons. Beyond 4 and 5, they will not be dissolving in the water, right? And let's look at this one, ethanol and 2-propanol. Now, ethanol is 2 carbon, and we need a hydroxyl covalent functional group. And here, 2 carbon needs a hydroxyl group, right? Now, we're going to fill the number and fill the hydrogens. So, numbering needs as 1, 2, and then fill the hydrogens, 3 hydrogens and 2 hydrogens here, and 3 hydrogens here, 1 hydrogen for the second carbon, and then third carbon also 3 hydrogens, right? Now everything is satisfied, 4 bonds for each carbon. We can write the condensed CH3 to the corner, CH to the middle, and then the OH is the functional group. Here CH within brackets OH, and then the ending with the CH3, the corner, right? That's how we write the condensed formula. Now line diagrams, corners are CH3 groups, the middle is the CH2 vertex. Here, the CH2 vertex is OH is kind of hanging there, right? That's how we show that. Now, we can also use here, count the carbon, C2, hydrogens are 6 and 1 oxygen. Here, the 3 carbons and hydrogens are 8 and then 1 oxygen. So you can write the molecular formula using the condensed or the Lewis structure, right? That's always a good practice to do it. Now, we're going to get some bigger examples too, right? And we want to get, let's say you're given the name 1-octanol. In this case, octa is 8 carbons. I'm going to draw 8 carbons connected to each other and number them one just to make sure that there's 8, right? And then the first one has the OH hydroxyl functionality. Fill the hydrogens to satisfy the 4 bonds for each carbon. 8th carbon has 3 hydrogens, 7 has 2, and then so on 2, 2, 2, 2 up to 1 carbon, right? Count the carbon C8 and H18 and oxygen. See whether I'm right, okay? All right. Now this part here, this part, whole portion, whole carbon chain is about, let me get it, it's about 90% of the molecule is carbons and hydrogens. It should be non-polar. And the OH is polar, and therefore the winner is actually the non-polar portion. So this should not dissolve in the water, even though it has the hydroxyl functionality, right? Because it's a trace amount of hydrogen bondings it can make. And the formula, you can just count the carbons and hydrogens, C8, H18, and 1 oxygen. Okay, let's say you're given this one, right? So I'm going to change this to, yes, let's get 3 carbon units, 1 OH, and then 3 methyl, 2 pentanol, another one given name, and then let's take another one given a line diagram for another alcohol. So we're going to name or draw them, and then we rank them too. Okay, ranking also important. Here 1, 2, 3 carbons, it should be 1 propanol, right? I drew something wrong, so that's why it's covered. So it's 1 propanol, and then here 2 pentanol, so 5 carbons. In the second carbon there's a hanging hydroxyl functional group, and then the third one should be methyl substituent, and then you're going to fill the hydrogens, right, just to satisfy the 4 bonds. Here you have you need 3 hydrogens, here 1, 2, and 3. Okay, now you have all, you can add the hydrogens, right? Now let's look at the other one. This one here, you have to imagine the corners are CH3s, and the middle carbon has no hydrogens because it's already 4 bonds there. So let's number it 1, 2, 3. So it should be 2 propanol, and the substituent is actually 2 methyl. So we can write 2 methyl. It's one name actually, all the way, and 2 propanol, 2 methyl, 2 propanol. This is also called the tert butanol. Just know if you want to know the name. Here the ranking. So this carbon, OH attached, one is attached to another carbon. It's called primary alcohols. Here this carbon hydroxyl group is attached to 2 carbons, the carbon attached to 2 other carbons. It's called the secondary alcohol. And this one here, the carbon attached to 3 carbons, it's called tertiary alcohol. Now also you can count the hydrogens. Primary has 2 hydrogens, and secondary has 1 hydrogen, and tertiary has no hydrogens in the ranking system. Okay, that's another way to memorize it, I would say. Okay, so let's get 2 other unusual examples. If I have this hexagon and hydroxyl group attached, you see the difference. Here each carbon has 2 hydrogens to satisfy the 4 bonds. In the benzene, the aromatic ring has 1 hydrogen for each carbon. So therefore, the first one is called the cyclohexanol because it's cyclohexane and 1 oil. This one is, just remember, phenol, right? Then a number of carbons, count them, 6, and hydrogens are 12, right? And 1 oxygen. Here, 6 carbons, 6 hydrogens, and 1 oxygen. Count them and see. Thank you.